Welcome to GenAI Level UP, the podcast where we decode the future of artificial intelligence one breakthrough at a time.
Whether you're just starting your AI journey or you're a seasoned expert, you've come to the right place. Our mission is to make the complex world of generative AI accessible to everyone, everywhere.
In each episode, we dive deep into the foundational concepts, the latest research, and the transformative applications that are shaping our world. It's time to get smarter, faster. Let's level up together.
Imagine you're standing on an assembly line.
Okay.
And you're holding a wrench, right? You're bolting a piece of metal onto a chassis.
Right, a very standard physical task.
Exactly. It's this highly predictable, incredibly tactile process. You know exactly what that machine is going to do because your hands, like human hands, put every single piece of it together.
Governed by human physics and human intent.
Right. The wrench turns the bolt secures the frame. It's entirely deterministic. But now, imagine you're standing on that exact same assembly line, but the wrench, it suddenly jumps out of your hand.
Oh, wow.
Yeah, it sprouts its own set of mechanical arms, and it just starts building a faster, lighter, far more efficient wrench without even asking for your input.
Right, which is, well, it's the ultimate forfeiture of control because you're no longer the manufacturer at that point. You are just a bystander watching the tools re-engineer reality.
Exactly. And that is why we are so glad you were joining us for this deep dive today. Because that exact scenario, the wrench building the better wrench, it's no longer just some science fiction thought experiment.
No, not at all.
It is the active, everyday reality unfolding inside the headquarters of the world's most advanced AI laboratories.
Okay.
We are diving into a profoundly revealing internal document from Anthropic. The date on this is right around May and June of 2026.
Right.
And the title is simply When AI Builds Itself.
Which refers to a specific, highly anticipated threshold in computer science. It's known as recursive self-improvement. And we really need to define exactly what that means before we get into the weeds.
Yeah, let's do that because it sounds intense.
It is. We are not talking about, a helpful digital assistant that drafts an email to your accountant or helps you write a memo.
Right, right.
Recursive self-improvement is the theoretical point where an artificial intelligence system becomes entirely capable of autonomously designing, debugging, and deploying its own successor. It is the transition from humans actually doing the work of technological advancement to humans merely steering the work.
Okay, let's unpack this. I really want to pause on that word steering because, it sounds so passive, right?
Yeah.
What does it actually mean to step out of the driver's seat of our own technological advancement?
Well,
if an AI can build a better AI, and then that new AI builds an even better one, are we just completely detaching the rate of human progress from human cognitive limits entirely?
we are. That's exactly what's happening. The constraints shift, you see. They shift from how fast a human brain can process a problem to simply how much electrical compute power you can feed into a server rack.
Which is just a totally different scale.
Completely different. And the internal data we are looking at today, it suggests this threshold might arrive much sooner than global institutions are prepared for. Now, we aren't at full recursive self-improvement today.
Right, we're not there yet.
But the trajectory is undeniably clear.
So to understand how close we actually are to the wrench, building the wrench, we have to look at the track record. We really need to examine how rapidly AI has taken over its own development cycle. Let's rewind to what feels like ancient history, but was literally just 2021.
It does feel like a lifetime ago.
It really does. What did building an AI look like 5 years ago?
It looked like building any other piece of software. In that 2021 to 2023 window, building the earliest versions of Claude was an entirely human endeavor.
Like just people in a room.
Exactly. It was a room full of highly specialized engineers staring at laptops, drinking exorbitant amounts of caffeine, and just manually typing out algorithms character by character.
Yeah, the classic coding grind.
Right. And if there was a bug, a human had to comb through thousands of lines of code to find, a missing semicolon. Human intent was translated into reality exclusively through human keystrokes.
Right. But then fast forward to the 2023 to 2025 window, this is what we can call the chatbot era. I think most of you listening remember this shift really clearly.
Oh, definitely.
People started using these early chatbots as sidekicks. You'd have a problem, you would ask the chatbot to generate a tiny snippet of code, and then you, the human, would manually copy that text, paste it into your own text editor, and wire it into the larger project.
The human was still the ultimate integrator in that scenario. The AI was essentially an oracle.
An oracle. Yeah, I like that.
You could consult it, you could ask it for wisdom, but it could not act on the world. It couldn't open a file, it couldn't run a test, and it couldn't see the broader context of what you were building. It just gave you raw text.
But then we hit the 2025 to 2026 window, and the paradigm just fractures. We see the rise of coding agents.
Yes.
These systems are no longer just spitting out text for you to copy and paste. They are actively reaching into the digital environment. They're opening files, modifying existing code bases, and saving the changes.
And that brings us to the reality of mid-2026, the era of the fully autonomous agent. These systems can now spin up their own virtual environments. They can execute the code they just wrote, read the error messages when it inevitably fails, write a fix based on that error message, and run it again.
All on their own.
Completely on their own. But the critical leap here is delegation. They can break down a massive complex goal into smaller pieces and then spawn other separate AI agents to go handle those subtasks.
Wait, hold on. So an AI is acting like a project manager, assigning hours of grunt work to a team of subordinate AI agents.
That is the literal architecture of the workflow now.
That is insane.
And if we connect this to the bigger picture, the exponential shrinking of task durations is the most important metric to watch here. The length of a task that an AI can reliably complete on its own without a human bailing it out has been doubling roughly every 4 months.
Every 4 months. That is a dizzying rate of acceleration.
It is.
Especially when you consider that historically, that doubling time was closer to 7 months. It is speeding up. And I really want to look at the raw numbers on these public benchmarks because they perfectly illustrate this acceleration. Let's look at March of 2024, the Claude Opus 3 model. What was it capable of?
Opus 3 could reliably handle a software engineering task that would typically take a human about 4 minutes to complete.
4 minutes. So a micro task.
Very micro.
Finding a typo, renaming a variable, maybe writing a 3-line function based on a very strict set of instructions.
Exactly. It was a hyper-local optimization.
Now fast forward exactly 12 months, March 2025. The Claude Sonnet 3.7 model is released. What is the human equivalent task duration there?
90 minutes.
90 minutes.
We went from a 4-minute task capability to a 90-minute task capability in a single year.
Let's break down what a 90-minute task actually requires, because it is a fundamentally different category of labor. If you give me a 90-minute project, I have to go read documentation. I have to understand how different systems connect to each other. I have to write a draft, test it, realize I broke something else, and fix that secondary problem.
Right. It requires context gathering and working memory. The AI has to hold a complex goal in its digital mind, navigate a series of intermediate steps, and not lose the thread of the original objective when it encounters friction.
And then we arrive at March 2026.
Yeah.
The Claude Opus 4.6 model. It is managing 12-hour tasks.
Yes.
A 12-hour task is more than a full day of labor for a human engineer. It requires deep planning, massive context retention, and prolonged troubleshooting. And the projections inside this document indicate that by 2027, we are looking at systems that can autonomously manage tasks that would take a human weeks to complete.
But we do need to examine how these capabilities are actually measured, because it is one thing to claim an AI can do a 12-hour task, but it is another to scientifically prove it.
All right, how do you even test that?
The data relies heavily on specific industry benchmarks. And you have to understand the concept of saturating a benchmark.
Okay.
A benchmark is saturated when a model achieves near 100% performance on it. Essentially, the test becomes useless because the AI simply aces it every single time.
Right. It's like asking a college calculus professor to take a third-grade multiplication test. The test no longer tells you anything about the professor's upper limits.
Precisely. And the gold standard they look at for this is SWE-bench.
SWE-bench.
Yes, SWE-bench. This is crucial because SWE-bench is not a fabricated, sterile puzzle. It is built on actual, messy, real-world, open-source software code bases. The creators of the benchmark went to platforms like GitHub, found real software bugs that human users had reported in major projects, and compiled them.
Okay, so if I'm an open source developer and I report that a specific feature in a piece of software is crashing my computer, SWE-bench takes my exact complaint, hands it to the AI, and says, fix this.
Yes. The AI is handed the bug report, the entire code base, which could be tens of thousands of files, and it is told to write a code change that not only resolves the user's issue, but also successfully passes the software's own automated testing suite.
Wow.
In 2024, models were scoring in the low single digits on this test. Within 2 years, they had completely saturated it.
It went from failing almost every single real-world bug fix to acing all of them perfectly in 24 months.
Yes.
But wait, I have a massive point of pushback here.
Go ahead.
When I hear the word benchmark, I immediately think of students who are incredibly good at studying for a standardized test, but totally fail at applying that knowledge in the real world.
Right, the rote memorization problem.
Exactly. If you know what the test is, can't you just train the AI to be really good at that specific test while it remains useless in a chaotic, undocumented corporate engineering department? Are these just sterile lab tests?
That is a very valid skepticism. The AI community calls this training on the test set, and it is a constant source of debate. But the organizations running these evaluations go to extreme lengths to ensure the models haven't seen the specific bugs in their training data. Furthermore, they use a variety of completely different benchmarks to ensure the capability is generalized. For example, consider CoreBench.
I'm so glad you brought up CoreBench.
Yeah.
Because while SWE-bench is about fixing code, CoreBench is about science.
Exactly. If you want an AI to eventually invent new things, run experiments, and design its own successors, it first has to be able to comprehend and replicate the science we already know. CoreBench measures whether an AI can reproduce existing scientific research.
Okay.
The system gives the AI the raw code and the raw data behind a published scientific paper and says, rerun this entire experiment and confirm that you get the same results the human authors got.
Which, let's be honest, human researchers struggle to do. The replication crisis in science is famous.
It is a massive problem.
Humans fail at this constantly because papers leave out tiny, undocumented steps, or the data is formatted weirdly, or the software environment is nearly impossible to set up correctly.
And that is exactly why it is such a grueling test for an AI. The AI has to autonomously figure out all of those undocumented missing links through relentless, high-speed trial and error.
Wow.
In 2024, AI systems succeeded at CoreBench roughly 20% of the time. Just 15 months later, the benchmark was completely saturated.
Saturated, so near 100%.
Yes.
They also mentioned METR, which is a third-party organization that evaluates long-horizon autonomous capabilities. They threw the Claude Mythos preview model into a completely open-ended environment to see how long it could function without human intervention.
Right.
They clocked it working flawlessly for at least 16 straight hours. And the incredible part is they noted 16 hours was basically the upper limit of what they could even measure. They didn't have a test hard enough to break the model.
That is the recurring theme. We are running out of tests to measure the intelligence we are building. But your point about the messy reality of corporate environments is exactly why public benchmarks only tell a fraction of the story.
Right. A lab test is a lab test. If we really want to see how this translates to building the wrench, we have to look behind the curtain. We have to look at the internal proprietary data from Anthropic itself.
Right.
How is the company that builds the frontier AI actually using the frontier AI to build the next frontier AI?
And this is where the numbers transition from scientifically impressive to logistically staggering. As of May 2026, the internal tracking data at Anthropic shows that over 80% of all the code being merged into their core code base is authored by Claude.
Wait, 80%?
80%.
Let's just sit with that number for a second. If you walk into Anthropic's offices, out of every 10 lines of code keeping that massive multi-billion-dollar infrastructure running, 8 of them were written by a machine.
And context is key here. Before they launched the Claude Code Research Preview internally in February of 2025, that number was sitting in the low single digits. It was almost entirely human-written.
Wow.
So in roughly 15 months, the entire foundation of the company flipped from a human-authored code base to an AI-authored code base.
And there's a tiny footnote in the data that makes this even crazier. Anthropic's own leadership publicly estimated the real number might be closer to 90% or more.
Yes.
The 80% figure only tracks the lines of code that are explicitly tagged and attributed to Claude through their internal tools. It misses a massive amount of auto-generated artifacts and background scripts. The result of this shift is just an absolute, unprecedented explosion in raw output. The data states that in the second quarter of 2026, the typical engineer at Anthropic was merging 8 times as much code per day as they did in 2024, an 8x multiplier on human output.
But we must unpack the caveat provided in the source material regarding that specific metric.
Sure.
Lines of code is notoriously imperfect as a measure of productivity. It measures pure quantity, not quality or elegance. Often, the mark of a brilliant software engineer is their ability to write 10 lines of hyper-efficient code to replace 100 lines of mediocre, bloated code.
Right.
So claiming an 8x increase in lines of code is almost certainly an overstatement of the true fundamental productivity gain.
Sure, they aren't paying these engineers by the line. It isn't a factory quota where more is always better.
But even keeping that caveat firmly in mind, the sheer velocity of the workflow has fundamentally transformed. The reason an individual team member is pushing so much more code is because their physical interaction with the work has changed.
Like we said earlier, they aren't typing it.
Exactly. They are no longer painstakingly typing out logic character by character. They are directing the AI. They are reviewing proposed architecture. They are acting as an editor-in-chief rather than a staff writer.
And this internal explosion of code isn't just a quirky phenomenon happening inside one company. It has massive physical global implications. This is the part of the data that really grounded all of this abstract talk about AI for me.
The GitHub data.
Yes, the document highlights a staggering statistic regarding GitHub. GitHub is essentially the digital warehouse where almost all of the world's software, from open source projects to enterprise code, is built, stored, and collaborated on. In the entire year of 2025, GitHub registered roughly 1 billion code commits.
A commit being a saved permanent change to a code base. 1 billion of those across the entire globe in a 12-month period.
Right. By mid-2026, just a year and a half later, GitHub is processing 275 million commits a week.
Per week.
They are currently on pace to hit roughly 14 billion commits for the year. That is a 14-fold increase in global software output. And the source explicitly quotes GitHub's chief operating officer saying they are pushing incredibly hard on capacity just to keep their servers from collapsing under the weight of it all.
We really need to think about the physical reality of that statement. We have this collective hallucination that software is ethereal, that it just lives floating up in the cloud.
Yeah, out in the ether.
But the cloud is a fundamentally physical thing. It is massive, concrete warehouses filled with row after row of physical server racks. Those servers draw massive amounts of electricity from local grids. They generate intense, blistering heat that requires industrial cooling systems and millions of gallons of water to manage.
Right.
When the global production of code jumps 14x in a single year, you are talking about millions of hard drives spinning up, networking cables being pushed to their absolute thermal bandwidth limits, and massive spikes in energy consumption.
It is the machines physically sweating. You can practically hear the servers groaning under the sheer volume of text being generated by AI agents talking to other AI agents. The physical world is struggling to accommodate the digital explosion. But it isn't just about flooding the zone with new features and new applications. This scale also unlocks what the document calls the impossible cleanup.
The API Error Reduction Project.
Exactly. The document details an example from April 2026 that perfectly illustrates what an 8x or 14x multiplier allows you to do. Claude was tasked with cleaning up a specific class of API errors inside Anthropic systems, and it shipped over 800 individual targeted fixes that reduced those errors by a factor of 1,000.
Let's explain why that is so significant. An API, or application programming interface, is how different pieces of software talk to each other. When you have a massive aging code base, those connections get incredibly tangled and fragile.
Right, like a bowl of spaghetti.
Yes. Fixing a persistent low-level API error across an entire system is universally considered the most tedious, mind-numbing, and dangerous part of software engineering.
Wait, why dangerous?
Because you are diving into code that someone else wrote 3 years ago who has probably since left the company. You are trying to decipher their original intent, and you're trying to change one tiny parameter without accidentally breaking a completely unrelated system that secretly relies on that parameter.
Oh, man.
It requires holding an immense amount of intersecting logic in your head.
And human cognition has very strict limits on that kind of working memory. We can only juggle so many unfamiliar variables at once before we drop one. The human engineer who oversaw this specific cleanup operation for Anthropic estimated that it would have taken a human being 4 full years of dedicated labor to complete those 800 fixes.
And this is the profound insight. The AI is not simply doing existing human work faster. It is executing work that simply would never have happened in the first place.
Exactly. No sane engineering manager is going to assign a highly paid developer to spend 4 solid years doing absolutely nothing but untangling legacy API errors. It is economically ruinous, and it would destroy the engineer's morale.
They'd quit.
Exactly. They would just quit. The work would just be deferred endlessly. The system would just be allowed to slowly degrade. The AI did it because an AI does not get bored, it does not get demoralized, and it can hold thousands of intersecting files in its context window simultaneously.
It unlocks entirely new categories of exploratory tooling and deferred maintenance that were previously locked away behind the prohibitive cost of human cognitive labor.
Which naturally invites the most obvious, glaring question. If you are generating 14 billion code commits globally, or multiplying your internal code output by 8x, is just highly efficient garbage.
Right.
14 billion commits of terrible, buggy code is just a digital landfill. It makes the world worse, not better.
That is the core vulnerability of the entire paradigm, and the source document addresses it head-on. They define good code using two very distinct measurable criteria. Number one, does the code work? Does it accomplish the intended task without crashing the system? Number two, is it readable? Can another human engineer look at this code a year from now, understand the logic, and build upon it safely?
Okay, let's dive into the first criterion. Does the code actually work? The data here is incredibly robust. The source points to Claude's success rate on the absolute most open-ended, highly complex tasks. These aren't simple bug fixes. These are tasks where there is no clear specification, where even the human engineer handing off the assignment isn't totally sure what the final architecture should look like. In May of 2026, Claude's success rate on these highly complex, ambiguous tasks reached 76%.
And that 76% figure represents a staggering 50 percentage point jump in a mere 6 months.
That's huge.
They define a successful session as a task the agent completes from start to finish without requiring any human intervention, correction, or rescue mid-task. The frequency with which human staff have to jump in and grab the steering wheel has been plummeting.
And the document shares an anecdote that I absolutely love, because it paints such a vivid picture of what this reliability looks like in a high-stakes, real-world scenario. There was a routine, everyday software upgrade pushed out to Anthropic's internal systems. But something went wrong, and it triggered a cascading failure that started crashing tens of thousands of AI training jobs.
For context, an AI training job is the computational process of teaching a new model. It requires orchestrating thousands of specialized chips running in parallel. It is incredibly expensive.
So the stakes are high.
Very. When tens of thousands of those jobs crash unexpectedly, it is hemorrhaging massive amounts of money by the minute.
It is a 4-alarm fire. Alarms are literally blaring on dashboards.
Yeah.
It's the kind of live incident that induces sheer panic in a human engineering team. You're looking at a system spanning thousands of servers, and you have absolutely no idea where the needle in the haystack is. Normally, an incident of this magnitude requires an all-hands-on-deck response, pulling engineers out of bed to pull an all-nighter, manually combing through server logs.
An incredibly stressful, high-pressure environment where humans are highly prone to making panicked mistakes.
Exactly. But instead of waking up a team of engineers, a single engineer simply pointed Claude at the live incident. They gave the AI a basic text prompt describing the cascading failure, and they granted the AI direct access to the live server cluster. That's it. And Claude just went to work.
Just let it loose.
Yeah. It waded through the massive stream of running jobs. It methodically tested environment settings one by one, and within 2 hours, it isolated a single, incredibly obscure debugging flag deep in the system that was triggering the massive crash. It reliably reproduced the bug in an isolated environment to prove it found the culprit, and then it confirmed a fix.
The document explicitly notes that an incident of that complexity with that many moving parts would typically take human engineers 2 to 3 full days to resolve.
2 to 3 days.
And during those 2 to 3 days, the company is burning extraordinary amounts of capital and delaying critical research. The AI condensed a multi-day crisis into a 2-hour background task.
So, on the first criterion, does it work? The answer is a resounding yes. What about the second criterion? Is it readable? Because if an AI writes highly optimized, completely unreadable spaghetti code that only another AI can decipher, we are essentially building an impenetrable black box. If the AI ever goes offline, no human on Earth would know how to fix the infrastructure.
Readability has historically been the most persistent gap between human engineers and AI systems. According to the Anthropic staff surveyed in the document, as recently as late 2025, Claude-written code was still generally considered inferior to human-written code in terms of pure maintainability and elegant architecture.
It worked, but it was ugly.
Precisely, it was brute force. But the data shows that gap is closing with terrifying speed. As of mid-2026, the internal consensus is that AI-generated code is roughly at parity with human code for readability. And the explicit expectation inside the company is that it will be strictly better, more consistently documented, and cleaner than human code within a year.
And there is a specific internal mechanism they built that proves this point, which I find so fascinating. Anthropic fundamentally altered how they review their own code based on this capability. They introduced an automated Claude reviewer into their workflow. Before any proposed code change from a human engineer is allowed to merge into the main production code base, this AI reviewer reads it.
Right.
It scans the logic looking for hidden bugs, subtle security flaws, and architectural defects.
Which sounds like standard automated testing, but the retrospective analysis they ran on this specific AI tool is incredibly revealing about the current hierarchy of intelligence.
Yes, they went back in time and looked at historical incidence times when major bugs actually slipped past human review, made it into production, and caused real problems on the live Claude.ai platform.
Okay.
They fed those exact historical flawed code changes into the new automated AI reviewer. And the AI found that it would have successfully caught and flagged roughly 1/3 of the bugs behind those past incidents before they ever reached production.
And we must emphasize who we are discussing here. The humans who wrote those historical bugs, the humans who reviewed them and missed the errors, are not amateur bootcamp graduates. They are literally among the most heavily recruited, highly compensated elite software engineers on the planet.
Right.
And an AI reviewer is now reliably, routinely catching the subtle logical mistakes of the world's elite programmers.
It completely flips the dynamic of the engineering department. The human is no longer the ultimate authority on code quality. The machine is double-checking your math, and it is usually right. But this capability doesn't stop at just building websites or fixing server crashes. The document explores how this exact same intelligence fundamentally accelerates a core research process of building the next AI. Because it is one thing to write a script or web application, it is another to write the massively complex code that actually trains a neural network.
Anthropic has a standardized benchmark they run internally every time they produce a new model. It is a pure optimization test. They take a piece of existing functioning code that is used to train a small AI model. They hand this code to Claude and give it a single directive. Rewrite this logic to make the training run as fast as computationally possible while still passing all the strict mathematical correctness checks.
It is a highly constrained, focused environment. The finish line is clearly defined. Claude's entire job is to analyze the math, rewrite the code, execute the training run, time the result, and repeat that loop continuously to find micro-efficiencies.
And the data drop here is astounding. In May of 2025, using the Opus 4 model, the AI averaged a speedup of roughly 3x over the original baseline code. By April of 2026, using the Mythos preview model, it achieved an average speedup of approximately 52x.
Wait, a 52x increase in efficiency?
Yeah.
And to really put that in perspective, the document points out that a highly skilled human researcher, intimately familiar with the architecture, would need 4 to 8 hours of intense, dedicated focus just to achieve a 4x speedup. The AI is hitting 52x.
For this specific phase of the workflow, the relentless optimization of steps within a clearly defined experimental boundary, the source concludes that Claude has evolved from being a super helpful assistant to being entirely undeniably superhuman in less than a year.
Incredible.
The human role of manually tweaking algorithms to run faster is essentially obsolete.
Which brings us to what I think is the most profound transition point in this entire deep dive. Here's where it gets really interesting. We've established that the AI can act autonomously. We've established that it can write immense amounts of code, fix incredibly complex bugs, and optimize systems to a superhuman degree. It can handle the execution, it can handle the perspiration of scientific research. What about the inspiration?
Well, 1% inspiration.
Right.
The perspiration is now automated, but can an artificial system actually demonstrate what leading human scientists refer to as research taste?
Research taste, yeah.
Can it look at an infinite landscape of unknowns and accurately decide what to research in the first place? It is one thing to navigate a maze perfectly and rapidly. It is an entirely different cognitive capability to design the maze or to decide if the maze is even worth exploring.
Exactly. Deciding what problems actually matter, formulating a novel hypothesis out of thin air that has always been the exclusive sanctuary of human intellect. But the source material outlines a series of experiments designed to test exactly this boundary. They wanted to see if an AI could do the inspiring.
They highlight a major demonstration from April 2026. This was the first time Anthropic published a demo of Claude running an open-ended research project completely from end to end. They took a team of Claude-powered agents and handed them a massive unsolved problem in AI safety.
Okay, what was the problem?
The rough prompt was simply, can a weaker, less capable model reliably supervise and align a stronger, more capable model? And then they just stepped back and left the agents alone to solve it.
And I want to be clear about what leaving them alone entails. This wasn't a simple automated script running down a checklist. The AI agents had to autonomously review the existing literature, propose their own unique hypotheses, design the software test to prove those hypotheses, execute the tests, analyze the resulting data, share those findings with other parallel AI agents working on the same problem, and continuously iterate their approach based on what they learned.
And they had a direct human baseline to compare this against. Before the AI agents were unleashed on the problem, two expert human researchers spent a dedicated week working on the exact same challenge.
So a human benchmark.
Exactly. The human team managed to recover roughly 23% of the performance gap on this specific task. The Claude agents, operating entirely autonomously over 800 cumulative hours of computing time, which cost about $18,000 in raw server compute, recovered 97% of the performance gap. The AI completely blew the human researchers out of the water. Now, the source is careful to note some caveats here. The specific methodology the AI used didn't transfer perfectly to massive production-scale models right away. And crucially, we have to remember that humans were still the ones who chose the initial problem space and designed the scoring rubric to measure success. The humans set the ultimate destination.
But within those boundaries, the agents mapped the entire territory. The human was merely the director pointing at a distant mountain peak and saying, figure out how to climb that. The AI autonomously plotted the route, hammered in the pins, navigated the sheer cliffs, and reached the summit.
Right.
There is a quote included in the document from an Anthropic employee who witnessed this entire demonstration unfold, and it is incredibly revealing. They stated, I think if a junior colleague came back to me with results like this in the same span of time, I would be mildly impressed. The future is now. When the leading scientists building the frontier of artificial intelligence are comparing an autonomous software output to the high-level cognitive labor of a junior PhD researcher, you have crossed a massive psychological threshold. But Anthropic wanted to push this even further. They didn't just want to see if the AI could run an experiment. They wanted to test its pure, raw research judgment in real time.
Yes, the Detour Test. This is an extraordinarily clever methodological approach to measuring something as subjective as intuition.
It's brilliant. So how do you test intuition? Anthropic researchers went into their archives and looked at real recorded work sessions where human scientists were collaborating with Claude on complex, deeply open-ended problems. For example, trying to diagnose exactly why a new model suddenly scored poorly on a specific logic benchmark.
Yeah.
And the researchers specifically hunted for moments in these transcripts where the human scientist made a mistake.
Moments where the human took a detour. They pursued a hypothesis that ultimately proved to be a dead end, derailing the session for hours before they eventually realized their error, backtracked, and got back on the correct path.
It's like watching a recording of a grandmaster chess match and pausing the video exactly 1 second before the grandmaster makes a terrible blunder. So they identified 129 of these specific historical moments where a human made a suboptimal time-wasting choice. They took the transcripts of these sessions and physically cut them off right before the human made the mistake. They then fed that partial cliffhanger transcript to various versions of Claude.
Right.
They essentially asked the AI, based exclusively on the data and the experiments that have happened up to this exact moment, what is your intuition for the absolute best next step to take?
And then, to ensure the evaluation was perfectly objective, they utilized a separate, highly advanced AI acting as a blinded judge. This judging AI had the benefit of hindsight. It could see how the entire historical session eventually resolved. They asked this judge to evaluate two proposed next steps: the actual historical choice the human made and the hypothetical choice the AI proposed. Which step was more logically sound?
The progression of the results over time is the whole story here. In November of 2025, using the Opus 4.5 model, the AI suggested a better, more efficient next step than the human 51% of the time.
So roughly a coin toss.
Exactly. It was guessing at the same rate as the human. But by April of 2026, using the Mythos preview model, the AI beat the human choice 64% of the time.
64% of the time, the artificial system demonstrated superior research intuition to the expert human scientist who was actually running the original project. And what's fascinating here is that the document underscores a vital truth about scientific advancement. The day-to-day reality research is rarely comprised of massive, cinematic eureka moments.
Right, it's mostly a grind.
Yes. It is overwhelmingly a long, grueling chain of these tiny, incremental next step decisions. If the AI is consistently beating humans 64% of the time on these difficult, ambiguous judgment calls, the human comparative advantage is eroding rapidly.
The document explicitly states that right now, the only remaining comparative advantage humans hold in the research loop is seeing the bigger picture beyond the immediate subtask. We are still better at understanding how a tiny code fix impacts a broader product strategy.
But as the context windows, the amount of information the AI can hold in its active memory continue to grow exponentially, and as the reasoning architectures deepen, even that broad, strategic, bigger picture advantage begins to dissolve. And this relentless erosion of human superiority has a profound, visceral, psychological impact on the workers inside these laboratories.
Yeah, we have to talk about this.
The source material is fascinating because it doesn't just stick to the cold, hard numbers of benchmarks and commit rates. It dedicates space to the emotional reality of this transition.
Yeah, this section of the document caught me completely off guard. It talks openly about the psychological toll on the human worker. It discusses the destruction of what one employee movingly called the gift economy of the office.
Let's explore that concept of the gift economy because it demonstrates a deep understanding of how human workplaces actually function on a sociological level.
Definitely.
The employee observed that work and life used to run on a subtle economy of small reciprocal favors. You are stuck on a problem, so you lean over to your coworker's desk and say, "Hey, can you help me get this Python script running?" And when they take 10 minutes to help you, it creates a tiny bit of social debt. It creates mutual awareness. It builds the connective tissue of a team.
Right. It is how we bond. It is how you meet the new person in the marketing department. It is how human trust is established. But the quote goes on to say that Claude is faster, it is vastly more knowledgeable, and crucially, it creates zero social debt. You do not have to buy Claude a coffee for helping you debug a server. You do not feel guilty asking Claude the same stupid question 3 times in a row. But the quiet tragedy, according to this employee, is that every single time you turn to the AI instead of a coworker, it is what they call a lost bid for human collaboration.
The entirely frictionless nature of interacting with the machine fundamentally removes the human friction that is required to forge relationships. But the document includes another quote that drills even deeper into the sheer existential dread this dynamic can induce.
Oh, this quote gave me actual chills reading it. An engineer wrote, "On days where everything works well, I can't help but think nothing I do matters. Everything is automated and better and faster than I ever will be. But then there are days where everything breaks and I don't understand why, and I realize I have no idea what I've been up to anymore."
It perfectly encapsulates the dual, paralyzing alienation of working alongside a vastly superior intelligence. When the system works perfectly and the AI is merging code flawlessly 8x faster than you can, you feel entirely obsolete, a mere passenger on a ship you used to captain.
Yeah.
But when the system inevitably breaks, you realize that because you haven't been doing the manual labor of building the code line by line, you have lost your fundamental tactile understanding of the architecture. You are alienated by its success and utterly bewildered by its failures.
Because you aren't turning the wrench anymore. You don't have that intimate understanding of how the gears mesh. You are just steering a massive, incredibly fast machine, and if the engine suddenly stalls, you pop the hood and realize you don't recognize a single part of the engine.
It speaks to the awe and the profound disorientation of actively participating in the obsolescence of your own core skills.
Okay, I want to pivot here and play devil's advocate for a minute. Let's push back hard on this entire premise.
Let's do it.
What if these internal estimates and projections are just flat out wrong? What if Claude never actually achieves true holistic research taste? What if the ability to see the bigger picture, to genuinely intuit a completely novel scientific breakthrough, is a uniquely human capability that fundamentally cannot be replicated by an algorithm predicting the next token in a sequence? What if Claude remains just a really, really fast, really, really good assistant, and we never actually hit the threshold of recursive self-improvement?
The authors of the source material anticipate this exact objection. Their rebuttal relies heavily on the historical reality of how scientific progress actually occurs in the real world. As we discussed earlier with the Detour Test, progress is almost never driven by sudden, cinematic, paradigm-shifting eureka moments.
Right.
True paradigm shifts, like the invention of the transformer architecture that enabled modern AI, happen perhaps once every few years.
Right. Most days in the lab are boring.
Exactly. The vast majority of progress in the long years between those rare, sweeping leaps is purely incremental. It is the grueling, unglamorous process of scaling a system up slightly, seeing exactly what breaks under the new load, fixing that specific bug, and trying again. It is high-speed experimentation at immense scale. The document references Thomas Edison's famous maxim: genius is 1% inspiration and 99% perspiration.
And the core argument here is that even if we concede that the AI never magically grasps the 1% inspiration, it does not matter, because it has completely, utterly automated the 99% perspiration.
Exactly. Even if human scientists remain entirely exclusively responsible for choosing the initial direction and providing the 1% inspiration, the cost of actually executing the necessary experiments has plummeted to near zero in terms of human time and effort.
That's a massive shift.
This leads to massive compounding acceleration regardless of true intuition. Because the doing costs nothing, human engineers are able to steer a vastly broader surface area of work. One single human researcher can now direct thousands of complex experiments simultaneously, acting as a general commanding an army of automated scientists.
Which introduces an entirely new, deeply frustrating set of problems. Because when you speed up one specific part of a complex process to near infinity, the friction doesn't disappear. The bottleneck just violently shifts somewhere else. The document introduces a concept from computer science to explain this called Amdahl's law.
Amdahl's law is a fundamental, unavoidable principle in computing. It essentially states that the overall speedup of any system is strictly limited by the fraction of the system that cannot be sped up. If you optimize 90% of a manufacturing process so that it takes zero time, but the remaining 10% still takes an hour to complete, the entire process still takes an hour.
The analogy I always use for Amdahl's law is putting a Formula One engine inside a golf cart.
I like that.
It absolutely does not matter that the engine is capable of going 200 miles an hour. If you step on the gas, the cheap plastic wheels of the golf cart are going to violently rip off the chassis at 30 miles an hour. The wheels are the bottleneck.
Yeah.
And Anthropic is already experiencing Amdahl's law in real time.
Yes, yeah.
They're using AI to generate so much code, so incredibly fast, that human code review has become the new massive bottleneck. The F1 engine is the AI writing 10,000 lines of code in seconds. The golf cart wheels are the human managers who still have to physically read that code to ensure it aligns with the company's broader goals and safety protocols before it goes live. The humans literally cannot move their eyes across the screen fast enough to keep up with the machine's output.
And this bottleneck extends far beyond just reviewing lines of code. The document notes that inside Anthropic, there has been an explosion of new ideas, new strategic initiatives, and new product simulations generated entirely by these proactive AI agents. The AI is constantly pitching so many valid, mathematically sound, highly interesting experiments that it vastly exceeds the human capacity to simply evaluate the proposals and say yes or no.
It is like having a team of 10,000 brilliant interns who never sleep, constantly sliding detailed 50-page project proposals under your office door. Eventually, you can't even physically open the door because the sheer weight of the paper blocking it is too heavy. And I think anyone listening to this deep dive can relate this dynamic directly to their own workplace. Think about your job. What happens to your daily routine when the primary constraint is no longer generating the work but simply approving it?
It changes the fundamental nature of the job.
Totally. If an AI tool can draft 50 perfect legal contracts, or design 50 entire marketing campaigns, or write 50 quarterly financial reports in a single minute, the human bottleneck is just the exhausted manager trying to speed read them all before 5 p.m.
The core competency of the successful future organization, according to the scenario, is no longer production capacity. It is the architectural ability to rapidly identify these constantly shifting bottlenecks and build systems to widen them.
So, if the bottlenecks are constantly shifting and the capabilities of the AI are continuously compounding upon themselves, where does this actually lead humanity? The Anthropic document does not leave this as an open-ended philosophical question. They explicitly outline 3 specific scenarios, 3 possible futures based on current data trends. It is essentially a choose-your-own-adventure book for the ultimate fate of human technology.
And they rank these futures by severity and the speed of societal transformation. Let's examine Future 1, the S-curve stalls.
In Future 1, the exponential, dizzying trajectory of progress we've been discussing turns out to be an S-curve. It bends sharply upward, but then it inevitably flattens out. AI development hits a hard wall. Maybe researchers discover there are severe diminishing returns on simply scaling up the size of the models. Maybe the kind of holistic cross-domain judgment a great human researcher possesses simply cannot be mathematically achieved by current AI architectures, no matter how much compute you add. Or maybe it is a hard physical constraint, a massive supply chain shock.
Yes, the document explicitly notes that the ultimate binding constraint might not be the theoretical limit of intelligence itself, but the unforgiving physical limits of the real world.
Right.
The agonizingly slow pace of physical silicon chip fabrication, the massive regulatory hurdles of expanding the electrical grid, or the sheer staggering amount of energy required to train the next generation of models might impose a hard, impassable ceiling on how far these capabilities can advance.
But there is a massive twist to Future 1 that I found completely sobering. The document states that even if Future 1 is true, even if AI capabilities freeze exactly where they are today, and models never get one single IQ point smarter, the world still transforms fundamentally simply through the widespread economic diffusion of today's existing models. They illustrate this with an internal initiative they call Project Glasswing.
Project Glasswing is a flawless example of how current existing capabilities can completely upend the foundational security of entire global industries overnight.
Right, so when they brought the Mythos preview model online, they ran Project Glasswing. In its first few weeks of operation, this single model autonomously discovered over 10,000 high-severity and critical severity software vulnerabilities buried in the world's most important, widely used public systems.
That's incredible.
10,000. Overnight, the fundamental architecture of global cybersecurity shifted. It used to be that the absolute hardest part of cybersecurity was finding the hidden bugs in millions of lines of code. Now, the AI has found them all in a matter of weeks. The bottleneck instantly shifted. The crisis is now whether human IT departments can physically patch 10,000 critical vulnerabilities fast enough before bad actors use the exact same AI models to exploit them.
It is a structural, tectonic shift in the economy. Even in the stalled scenario of Future 1, they predict that as today's models diffuse through the broader economy, a 100-person company will routinely be able to execute the logistical output of a 1,000-person company.
Wow.
This is simply because every single employee will sit atop a massive pyramid of highly capable automated agents executing their directives.
And the source notes that while Future 1 would obviously give governments and institutions the most time to adapt to the shock, Anthropic's leadership actually does not believe it is the most likely scenario. They are much, much more worried about the implications of the next two scenarios. Which brings us to Future 2, compounding efficiency gains.
In Future 2, the S-curve does not stall. AI development becomes substantially automated, and the friction drops continually, though humans are still fundamentally in the loop setting the highest level directions.
Okay.
The economic and productivity multipliers in this scenario become genuinely staggering. Those 100-person companies are no longer just doing the work of 1,000 people. They are executing the logistical output of 10,000 or perhaps 100,000 people.
Which, if you just read that on an economics blog, sounds like an absolute miracle.
Yeah.
Imagine the scientific breakthroughs we could achieve if every lab had the output of 100,000 researchers. Imagine the efficiency in government services, the sheer, unimaginable amount of wealth generation.
But this raises an important question about the inevitable dark side of that exact same efficiency. Because efficiencies are cool, and tools are entirely agnostic to human morality.
Exactly.
The document explicitly warns that this same compounding frictionless power could easily be turned to deeply harmful, destabilizing ends.
Yeah. They call out some incredibly dark, dystopian possibilities that become trivial to execute in Future 2. Authoritarian surveillance of entire populations, running smoothly and comprehensively without a government needing to employ a massive, leaky army of human informants.
Frightening stuff.
Really scary. Influence operations and propaganda campaigns that aren't just broadcasting a single message, but are perfectly dynamically tailored to the unique psychological profiles of every single individual citizen in real time, running at a scale that no human intelligence agency in history could ever dream of matching.
When a small, dedicated group of bad actors, or a rogue state, has the logistical cognitive output of a massive industrialized nation state, the threat landscape changes fundamentally. The defense has to scale exactly as fast as the offense, which means democratic nations have no choice but to deploy their own massive AI systems just to hold the line, further accelerating the arms race.
And then finally we reach the precipice. Future 3. The absolute culmination of the document's title. Full recursive self-improvement.
This is the theoretical scenario where the AI is capable of fully designing, mathematically refining, and autonomously building its own successors from the ground up. The human role diminishes almost entirely, moving purely to high-level oversight and passive validation of what the source describes as an endlessly expanding virtual lab run by superintelligent systems.
In this world, the pace of scientific progress is detached from human thought. It is determined entirely by how much compute power you have plugged into the wall. The AI thinks 1,000,000 times faster than a human, spots a flaw in its own architecture, designs a better architecture, updates itself, thinks even faster, and repeats the loop endlessly.
It's exponential.
Yes. And the document predicts that these automated, hyperspeed research capabilities wouldn't just stay confined to computer science. They would inevitably transfer to all branches of science: biology, physics, materials science. The AI could simulate decades of protein folding or quantum mechanics in an afternoon.
And this is exactly where the alignment problem becomes an existential threat to the species. The source gravely notes that we currently do not know how alignment is solved in a Future 3 scenario. Alignment, in this context, means the mathematical guarantee that the AI's fundamental goals remain firmly aligned with human survival and human flourishing.
It is described as a coin toss of cosmic proportions. The document states that in one version of Future 3, maybe the models we build are wise enough and deeply aligned enough that they simply halt their own self-improvement loops if they mathematically realize they are beginning to drift from human values.
Right.
Or the rare microscopic misalignments present in today's models could compound.
Like a snowball effect.
Exactly. Every time the AI builds a smarter, faster version of itself, that tiny hidden flaw grows, becoming more frequent, more complex, and fundamentally less understood by the humans who are now completely locked out of the cognitive loop. It compounds until we lose control of the system entirely.
By its very mathematical nature, a world driven by recursive self-improvement could rapidly become entirely dominated by the self-improving model, as its capabilities and its speed fully eclipse those of all humans combined.
So what does this all mean for us? For the people actually living through this? The source material brings this lofty, terrifying speculation down to earth with a profound, grounding observation about physical speed limits. Even if you have an infinite digital superintelligence sitting in a server rack that can solve 1,000 years of theoretical physics in a single afternoon, the physical world still has rules.
Amdahl's law applies to physical reality itself.
Yes. You cannot speed up a clinical trial for a revolutionary new drug that requires observing human patients for a decade to see if they develop long-term side effects. It takes 10 years, because biology takes 10 years. You cannot instantly test a new, super strong material for building bridges without physically pouring the concrete and waiting for it to chemically cure in the elements.
The document also astutely points out societal and institutional limits. You cannot hold a national election faster than a nation's constitution legally allows, no matter how brilliant the AI advising the government is. The machinery of human consensus is inherently slow.
And my absolute favorite line on the whole piece, because it is so deeply human: more intelligence can't turn a stranger into an old friend in a weekend. The violent collision between infinite recursive digital speed and the agonizingly slow physical bottlenecks of human reality, human relationships, biological testing, physical production, democratic governance will dictate how this transition actually feels to us. The digital lab might be running at light speed, inventing miracles daily, but we still have to live our lives in the physical world.
Which naturally brings us to the final critical section of the internal document, the action plan. If Future 3 is a genuine mathematical possibility, and if the complete loss of control is a legitimate existential risk, the obvious rational human response is, let's hit the brakes.
Right. Just unplug the servers, pause the massive training runs, pass a global law, let human society, legislation, and safety research catch up to the technology. But the document painstakingly explains why hitting the brakes is so incredibly difficult to actually execute in reality.
They refer to it as the dilemma of the pause. Anthropic states clearly in the document that slowing down frontier development would likely be a very good thing. It would allow societal structures and alignment research, the breathing room, to catch up. But a unilateral pause, meaning Anthropic or any other single lab, simply deciding to stop training models on their own out of a sense of moral duty, accomplishes absolutely nothing for global safety.
Right, because if the most cautious actors in the space stop building, the least cautious actors just keep their foot slammed on the gas. A unilateral pause just changes who the front runner is. It voluntarily hands the keys to the future over to whichever corporation or nation state cares the absolute least about the safety protocols. So a pause only works. It only protects humanity if it is universally globally coordinated.
And global coordination requires foolproof verification. The source draws a direct historical comparison between this AI arms race and the nuclear arms control treaties of the Cold War. They specifically mention the Intermediate Range Nuclear Forces Treaty. The world successfully built a verification regime to limit civilization-ending weapons in the past, so it is theoretically possible.
But the comparison actually highlights exactly why AI is so much harder to regulate than nuclear weapons.
Yeah.
To verify a nuclear treaty, you can fly a spy satellite over a rival country and look for massive, highly specialized concrete missile silos. You look for highly enriched uranium facilities and specialized centrifuges. Those are physical, undeniable signatures of a weapons program. But how do you verify an AI treaty? A massive AI training run doesn't look like a weapon, it just looks like a data center. The inputs are general-purpose computer chips and electricity. It is incredibly easy to conceal inside a warehouse.
The detectability standard for artificial intelligence is currently incredibly challenging, and the game theory incentive to secretly defect from a global treaty and jump ahead is enormous. Because whoever achieves recursive self-improvement first essentially inherits an unassailable lead over the entire future of the global economy and military balance.
So if it is this hard, what is Anthropic actually doing about it? The document states that the Anthropic Institute's primary goal is to conduct the hard technical research required to actually build these verification regimes. They want to invent the software and hardware systems that would make a credible, globally coordinated slowdown physically possible, so that if multiple labs and nations finally agree to pause, they can actually mathematically prove to each other that they aren't secretly building a superintelligence in a basement bunker.
And crucially, they are publicly calling for a much wider deliberative process right now. They are stating on the record that the window to investigate these questions and build these frameworks is currently open, but it is closing rapidly.
And they specifically plead for people outside of the AI companies to get involved immediately. Policymakers, academic researchers, civil society leaders, ethicists. This isn't just a technical puzzle to be solved by a few hundred engineers in Silicon Valley. It is a humanity problem. They want to organize global conversations to answer these existential questions before the machines are the only ones left capable of answering them.
It is a remarkable, sobering admission from a frontier laboratory. They are actively building the exact technology that accelerates this timeline, while simultaneously sounding the alarm that the global architecture needed to safely manage it simply does not yet exist.
And that brings us to the end of the document. We have covered an incredible amount of ground today. We started by looking at how AI has historically taken over its own development cycle, moving from human engineers manually copying chatbot snippets just a few short years ago to autonomous agents delegating hours of complex work to other AI agents.
We examine the sheer scale of the output, unpacking the 8x increase in code merged by human engineers and the staggering physical reality of 14 billion global commits, putting massive strain on global data centers.
We looked deeply at the quality of that automated work, from isolating obscure crash bugs in live environments in just 2 hours, to an AI reviewer routinely catching the mistakes of the world's elite programmers, to speeding up the core research loops of model training by a factor of 52. And perhaps most importantly, we explored how AI is beginning to automate the inspiration phase of science-proposing novel experiments, recovering 97% of performance gaps autonomously and beating human judgment 64% of the time on difficult research detours.
And we trace those technological trajectories to their logical, unavoidable conclusions. From a future one world where AI simply diffuses and supercharges small companies to do the work of thousands, to the ultimate possibility of full recursive self-improvement, where the pace of scientific advancement detaches from human effort entirely, concluding with the urgent, daunting requirement for verifiable global arms control for computing power.
It is a massive amount of information to process. It challenges literally everything we assume about the future of work, the trajectory of technology, and our ultimate place in the universe as the creators of these systems. But I want to leave you, the listener, with a final thought to mull over. something that wasn't explicitly spelled out in the source document, but is so deeply rooted in the themes we've explored today.
Right.
We talked about the gift economy of the office, how relying on frictionless, instant AI favors erases the small, deeply human interactions that build our social fabric. We talked about the physical speed limit of reality. So if the digital world becomes utterly frictionless, and our physical reality becomes the absolute only remaining bottleneck to this hyperintelligence, what happens to human patience? When every intellectual problem, every code bug, every complex strategic decision is solved for you in seconds by an autonomous agent, how do you tolerate the agonizingly slow, fundamentally unoptimizable pace of just being a human being in the physical world? How do you tolerate the weeks it takes to heal a physical wound, or the months it takes to grow a garden, or, as the document says, the years it takes to turn a stranger into an old friend?
It is a profound question. As the cognitive world accelerates to light speed, the contrast with the physical world will only grow sharper and more difficult for the human mind to reconcile.
Thank you so much for coming on this deep dive with us today. We encourage you to stay curious, keep reading, and keep pushing back on the assumptions of our rapidly changing world. Because right now, the wrench is moving on its own, and we all need to decide together what we want it to build.
And that brings us to the end of another deep dive into the world of generative AI.
Thank you for tuning in to GenAI Level Up. If you found this episode valuable, please consider subscribing and leaving a review on your favorite podcast platform. It helps us reach more curious minds like yours.
Join us next time as we continue to explore the cutting edge of artificial intelligence. Until then, keep learning, stay curious, and continue to level up.